Thank you, Frances, and thank you, the Foundation Bank Inter, for the opportunity. I prepared a presentation with slides, but reading the email from the organization, I remembered, well, the recommendation not to use slides, so I said, okay, no slides. Sorry about it. I thought I'm not going to be the only one using slides. So I prepared some notes. So I will be talking about how we use math in terms of artificial intelligence resources to tackle the pest evolution in crops. And I will put you in an example that we have deployed in Europe in more than 1.5 million hectares, so it's quite demonstrated that the technology works. But first, well, easy to see. As I mentioned, we are a mathematical company, a startup. We decided to tackle the shortage in the supply of food by applying data-based technology in providing the technicians and the users of pesticides, in this case, with anticipated knowledge, so they can use more efficiently the chemicals. So they use less chemicals, and they use the chemicals where it's needed and not where it's not needed, and when it is needed and not when it is not needed. How we do it? Well, we use data, which is open data, coming from satellites, not the images, not the patterns. We use the data layers from Sentinel satellites. Open data in Europe, you can take more than 9 different data layers from the satellites. We use weather data, current and forecast, again, forecast coming from the European Union, and also the USDA. And we use all the data related to the crop. I mean, geographical data, variety, and the most important one, how they count the pest. They are the technicians. Today, in the integrated pest management system that is widely deployed in Europe, the way they do it, and I go to the example of the olive oil, the way they do it is they count the insect. So they put traps and they count insects. They count eggs, they count female insects and eggs, because at the end of the day, the damage is when the fly sticks the olive and then the olive falls down, and then you lost that production. That lost is 30% of the total olive oil production in Europe is lost because of a fly. So they tackle that problem with pesticides. The problem is that pesticides are increasing the effects on the atmosphere, soil, the crop, and us when we consume the oil. So the predictive pest management, which is supported by the European Union, as a matter of fact, there is a directive that obliges the reduction of pesticides by 50% in 2030. The European Union recommends to use biopesticides, which is good, not as effective so far, and digital solutions to know how to tackle the problem with less use of pesticides. Well, this is what we do. We have deployed that, as I mentioned, in 1.5 million hectares in Portugal, Spain, Italy, and Greece. And we do it combining all those data and running the algorithms to detect which is the combination, the multivariable combinations of the causes that produce the evolution of the pest. And this is a pest very dangerous because it's exponential. If you tackle it on real time, today you don't know that in 3 days or 8 days, the number of flies affecting your crops is going to be huge because it's exponential. They grow exponentially when the conditions are good for them to hit the olives. So again, 30% of the olive production. You know that the olive oil today is at almost 8 euros per kilogram. 1 year ago was 3, 2 years ago was 2.5 euros per kilogram. So the shortage of olive oil is affecting us also in the availability to take that oil in our food recipes. So We combine three ecosystems. We combine the soil and the tree. We combine the weather and the fly. And I mean numerical ecosystems. We are not biologists. We are not agronomists. We are mathematics. So variables are numbers for us, and we combine them in the algorithms to know how they multi-relate. So we are able to anticipate 4 weeks in advance, which is going to be the evolution of the pest. How we anticipate that? Well, if we count the current flies in the trap, what we predict is how many flies are you going to have in that trap in the next 4 weeks. Well, that allows the technician to know where and when they are going to need the use of pesticides very precisely, so they are not spraying all around. The need is that we have to have a very accurate tool, because if we are not accurate, we are not providing the future evolution. So the accuracy, we have been deploying this in the last 3 years, as I mentioned, in a wide area in Europe, in olive oil. And the accuracy for no risk in the next 2 weeks, so saying you are not going to have risk, don't spray, is 90%. And the accuracy of you are going to have a risk in 2 weeks view is 80%. So this is a good tool for the users to anticipate and not spraying when they don't need it, and anticipate and prepare everything, and they can also spray biopesticides. So this is a tool that is kind of a brain that provides which is going to happen in 2 weeks with a high accuracy, so they can act in advance. This is data-driven smart decisions with a predictive solution. Which is very important is that you need data to train the algorithms. So sometimes you don't have the data. The data, satellites, weather, you have it. The conditions of the crop, you have it. But maybe you don't have traps. You have not been counting the insects in the past. So you can't train the model if you don't have data. What we have developed is a similarity, let me allow that word, similarity technology with math, that training the model in the south of Spain, where we have been counting pests, the fly, olive fly pest in the last 20 years, and is widely spread in the region with different conditions, altitudes, and varieties. We train the model in Andalusia, and we can deploy that model in Greece, where they have no data yet. The accuracy is less, 10% less, so 80, 70%, which is good. But in the last 3 years that they are counting, we have been increasing that accuracy to the 90 and 80% as we have in Spain and Italy. So this is quite good tool because can be scalable at any area, even though they have no data or not representative data. So this is one of the most important aspects of the artificial intelligence tool. And I would say that the second one is that provides a technology, a kind of a brain that can be used with different sources of data. So if you install automatic traps that are already in the market, and then you have not to go and count, but an automatic traps is going to count the flies, or you are not going to spray, but a drone is going to spray where the tool says that they have to spray, then the efficiency is much better. So combining precision agriculture, automatic traps, drones, with predictive agriculture, which is the AI tool, the result is impressive. And this is what the big chemical companies now are doing to tackle particularly this pest. Thank you very much.
Pedro, thank you. Thank you both. And we do have time for a few questions before we'll break for coffee, if we have any around the room right now. I have one set up for you right away, and that is about scalability with your, you produce a very affordable GPS system. What's the prospect for it taking off around the country, around the rest of the world? It seems like a very useful and easy option. What's your competition? And
yeah, the competition is selling similar devices with the same accuracy. We are actually the ones with the lowest price, but I mean, the difference is not that big, and there's market for everyone. We sold in 5 years more than 50,000 receivers, not all of them for agriculture. They are being used for surveying and other applications. But so it's hard to change people's mind to let them know that they can do the same with a 200 euro receiver that they can do with a 20,000 euro receiver. The first thing they say is, okay, that's not possible.
Quickly.
But once they try it, yeah, they are convinced.
Thank you. Question on that.
Thank you very much for your presentations, really interesting. So I have two questions. How are you creating trust on your audience, on your clients? Because I think that's a challenge, no? If we're providing results, how they trust the results. And the second question is about validation of the models, of the results. What are the strategies that you are following to, probably both are connected, but yeah, validate that the results are good enough, this 90% or 80 or 70% that you were saying before? So how you validate, or is that, because that's one of the questions that artificial intelligence technologies have right now, no? Validation. Thank you.
Thank you, Adrian. As I mentioned, we count, we predict the counting of the flies. So when we say that in 2 weeks, they are going to have 20 flies in the trap, before using the tool to action, the first year, in the first campaign, they went to the trap and compared our prediction with the current counting. And they do that in more than 3,000 different traps. And that's 90 or 80% is the average of those 3,000 different points of comparison. And they did that in the last 2 years. So one campaign, they say, okay, it's good. Let's do the following campaign. Okay, it's good. They do it during 3-4 months that the fly is active in Europe, July, August, September, October. At the third year, they say, okay, they go with an app to the technician with the map, the risk map, and they say, act as this map is showing.
We had 2 more questions. I think we can, there was one over here, and go ahead.
Yeah, this is a question for Pedro, or comment. Monitoring wildlife in fields like bugs and bees is something very interesting to address the biodiversity. I'm not sure if you guys are aware that something new is coming in the EU, is the biodiversity credits, like the carbon credits. And there is an Italian company that we have evaluated in the EAC accelerator called 3B, and they do exactly like you, but they have sensors in beehives, 5,000 sensors in beehives, monitoring the hives, the bees. If they are if they are healthy, that means the surrounding biodiversity is good. They also have capturing the sounds of different birds and bugs, and also the satellite images. With these three inputs, they are doing this. They want to predict and track the biodiversity in Europe. So I think it might be a good connection with your farmers to have an extra incentive to do things like this with the biodiversity credits. Thank you.
Thank you very much. No doubt about it. I think it's really interesting. I heard about that company.
I can talk to you later on.
Later on. Sure. Very interesting.
I was missing this side of the table. But Julie,
thank you. Thanks so much for the very interesting presentations. My question is for Josep. In the traceability space, a key step and one of the most challenging is to gather the polygons of the farms, but we just need to do this once per farm in millions of farms. And my question is, if we are working in a very remote area, can we use a mobile station and use it just once, the module, or do you need a kind of a fixed station?
No, if you don't have infrastructure like here in Spain, you can just put one of these cheap receivers. They can work as a base station, or you change the configuration in 5 seconds, and they can work as a rover. So you can put it in the same, let's say, in the same location, even if you don't have the exact coordinates of that location. If you always put the base station in that location, you will have relative centimeter accuracy, which for agriculture is enough. You don't need absolute centimeter level accuracy.
Thank you.
Go ahead.
Yes, good morning. Thank you to the three of you. I have a question, especially for Ramon, but everybody's welcome to answer. We talk about models in which farmers are going to be sharing equipment and it's going to be, much more efficient. But my question is, how much the farmers have participated in this model, and what is going to be the plan to actually educate and make them really participate into this? I mean, I've dealt with thousands of farmers in my life, and they all think their tractors is the best one, their field is the best one. So there's really a challenge there sometimes implementing these technologies. What is your approach to that? And we'll be welcome to hear from the others. Thank you.
To answer this question, so what we have seen is that the pressure on local farmers, small mid-scale farmers specifically, is so high at this point that they tend to be in general more open-ended than in the past, where they were more protective, right, about working in their fields with their equipment, with their teams. So obviously they can retain a fair amount, the property and a fair amount of the operations. But what we have seen is that the traditional cooperative system that served a fantastic role a century or 150 years ago has become not enough to address the complex challenges that we observe in the food industry today. So as a result of that, the level of food self-sufficiency of critical regions in the world is very low. To give you an example, in Massachusetts, approximately only 18% of the food that's being consumed in the Commonwealth of Massachusetts is produced in less than 250 miles. In Catalonia, it's a bit better, but not much better than that. It's maybe 25%. But what it means is that the level of self-sufficiency is so low that if it were to be a global crisis or a war or any type of global conflict, the food supply systems could be dramatically hurt, and the price of the food products in the supermarkets and markets would go up dramatically, and that would be affecting everybody, right? So as a result of that, what we have seen is that when we've been having interviews or collaborating with our local partners, they are increasingly more and more open to collaborate and to share infrastructure. I'm just going to give you an example. There was a food hub in Worcester, Massachusetts, 1 hour west of Boston, and it was only composed of 11 farms. When we did the regional analysis, we learned that they needed at least 350 or 400 farmers to collaborate and to increase their vertical integration presence to have enough power to negotiate trade agreements, etc. Otherwise, it would be too small in the food value chain, right? And they understood that, so they're growing and they're growing. It takes time. There's cultural aspects to it that you're referencing very smartly, and you're absolutely right. And it's going to take a mental or a psychological shift in a way. But what we have seen is that up to this point, the infrastructure sharing systems that are in place for the most part are absolutely insufficient. So they really need to go well beyond the first phase, which is the commodity one, incorporate all the processing, all of it, or the overwhelming majority of it, incorporate all of the packaging and labeling, or the overwhelming majority of it, and then as much as possible, the logistics and transportation, and when possible, at least for some channels, even the retail. If they're able to have this broader control over their food supply chain, their presence in the market could be growing tenfold, approximately, from 7% up to 70%. It may take 12, 15, or 20 years. It needs to be done regionally, but we think it's the way to go. And if they're able to combine those three strategies, economies of scale, vertical integration, and product sophistication, we foresee these communities increasing the quality of their products, tripling their sales and contributing to the local sourcing by twofold or maybe 3 times in the coming years.
Thank you, Ramon. Coffee. I think we've started it's a great session. I want to thank our 3 panelists right now, and I know
Thank you.
we've started some great conversations, so let's break for coffee for 20 minutes and then come back in here and keep the conversations going. Thank you so much.